Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, May 20, 2021, Thursday. And this is in continuation to talks about quality, and title is Civil Field Engineering Quality 19 Impact on Activities, Designs, Construction, Methods, Contracts, AnnexSL Quality, etc. etc. Whatever is related. This is in continuation to all that one, and these certificates. This is P certificate, that is this one, and this is another certificate, Chartered Engineer. This is another certificate, Fellow of IEI, and then quality noting, and certain file and more files. I'm showing you for certain reason. Sorry. For certain reason that when we say quality issue, these certificates give some competency, declare some competency is achieved. It must be witnessed, it must be exhibited, it must be demonstrated during work. For that purpose, these certificates mean. Otherwise, these certificates got no meaning. That's my contemplation. Maybe it's different for you. It could be different for you. My contemplation is that I understand. And my contemplation is that yours will be different. So I'll close this now. Quality. Quality is a primary requirement, you can say. It's a requirement that cannot be discarded at any cost, even if it's charity work. I mean to say, even if professional is paid or it's not paid, or if you are getting some material free, this does not mean that you grant exemption to required quality. There can be no adjustment and no compromise to quality. We people in this country have to understand, and not only we people, we specific people, special people who are called engineers. I am calling special because we have some certificate with us, that we got some academic qualification and then professional qualification, which claims or support our claim that we have some speciality in doing job. Our job as engineers is different. It's not an ordinary job. It's a job that requires mind, that requires work of mind, that requires design, that requires work on site or work in factory, and that requires supervision, that requires surveillance, and that requires whatever is not required in ordinary field. I want to try to explain every day in different scripts. It's my intention that construction of quality term should be made very clear, explicit, and nothing should remain implicit. When I say that, this means I must define quality in different approaches, in different variant designs, because quality is required everywhere. There is no place in universe where quality does not exist. It's up to us to understand by analytical meaning which part is quality and which part is quality and quantity. I mean to say, there may be some part quality and quantity, there may be some part quality, and there may be some point something else. We have to find out system exists there in quality and quantity. What does it tell? Whether this applies to product? Yes, it applies to product. When I say quantity and quality, that applies to product, or you can say element. And when I say quality, it applies to system. Try to understand what I say. When I say quality product, it's a product delivered by an approved system. And when I say quality on material, this does not tell that, but this tells us this material is having certain tested criteria. This material, this substance, or this product has passed through certain defined criteria. It meets those criteria, those requirements. I am just giving you some fragmentation of this. Quality, quality plus quantity, and quantity. These three are different terms. When I say simply quality, this means it applies to whole system. Whole system. System comprises of a train of activities and train of processes. All those train members, train bogies come under quality from initiation of something to delivery of that, under certain organization, by certain organization. This point is very much important, and we should understand in that regard. When I say quantity, this means I accept material just because I have to get that material without being clear about quality and assuming it might be having that much quality as promised or as claimed. This is what I want to explain. And then it's only quantity. It says, okay, it is. That's it. Quality and quantity means product acceptance. Okay, come on further. I raise a question that quality is required everywhere. And of course, you would say, yes, I understand. You would say, yes, it should be. But my question to you is, what is your contribution to make sure that quality existed or exists in this material? You just bought this material without any questioning, without any, you can say, considerable talk, without trying to know from either manufacturer or vendor what you are getting. You are just assume, okay, it is, and you buy it. That is your outlook. Maybe everybody cannot go to that extent, but as far as engineers are concerned or professionals are concerned, they have to, because I pay money for what? I pay money for requirement. Yes, quantity is my requirement, quality too is my requirement, but I would say on the other hand, first preference should be quality. quality of system and quality of product. Then quality of that person who is involved in this, like that person who designed this, and that person who is producing, who produced this, and that person like me who is buying. There are all persons involved. Buyer is a user, and product producer, a person who produces is a manufacturer, and a person who designs is also designer. All are in chain. We cannot directly meet everyone, but we can directly meet product, element. First we have to develop attitude of ourselves as buyer. What I want to buy, I want to buy keeping an eye on price or price discount or some other facility company gives, say one free for one, or I have to see real composition of that product. That attitude we have to check. I have to check, you have to check. We feel happy, see I'm getting this benefit with that. But why shall that manufacturer give you this benefit? For what? Okay, promotion can be one part. What generally happens, how can you say? Just like material on sale. They clearly say this is obsolete material or soon going to be obsolete. That's why it's on sale. Otherwise, new material can never be on sale. This means it had quality. Now this material is obsolete. One part is that. And then dedication. What is dedication here? Dedication should be in all phases of that product. That is dedication, devotion. But it's too difficult for every buyer to understand. There are other parameters also. We have already explained. Now, quality for product in construction, quality for materials that we buy in construction. There is a long list, very, very long list. It is long for citizen, for resident, for buyer, but it cannot be called long for engineers who constructs it or executes it, that project execution. For designer, maybe this list is informative for designer. For engineer who designs, this list could be informative, and that designer goes through that list from different viewpoint. But my requirement is this, or this material fulfills my requirement. My requirement is not designer's requirement, but project requirement. That is, in the scope of the designer to make sure what codes require or what use requires. That material has that capacity to satisfy. But person who is going to work on site or in factory, that person has different attitude. That person wants to see what is designed, I have to do according to that, meeting full requirement of designs. That person is not going to see complications of other points which designer has worked. But that person wants to see, okay, if it is a part of contract, I will make a review of that. And to find optional solution, you can say alternative solution. But that's limited. That person as contractor or whoever, whatever role that person adopts, it's fine. This is my role. I am paid as much as this, and I have to do this much. So it varies from person to person. That's why I say we have to, according to job description, think of. But construction is different. Construction contexts are different. Construction people have different variants, different, capacity. Contractors, those who are in contracting, they want to make as much profit, commercial profit as possible. They're not interested to that level in quality achievement or quality attainment. They're not interested to that level as designer expected. And user, or you can say customer, is interested in everything which he does not know. Yes, he was saying, "Oh, I should get customer satisfaction." But Napudi defines what is customer satisfaction. In every organization policy paper, you shall find customer satisfaction is our aim. But nobody defines in that policy what does customer satisfaction mean. That is very important part. I have not written that in this statement, but I will write later on. That customer satisfaction certainly relates to construction, if it is construction work, or relates to something else, which it is that. Maybe service, maybe something else. Though we use two terms only, product and service, but life is different. You can say then how that person should know what is he getting, what he gets, is saying, what's told, what is guaranteed. Because guarantees are written with disclaimers. Guarantees are written that something is beyond our control. Even these circumstances, in this situation, we give this guarantee, or else this shall not be valid. What does it mean then? It means you are getting money for a product from customer. You claim I do it, but at the same time you are saying beyond my control are circumstances. But question is, person who is paying, that person does not understand anything in these warranted conditions, but believes okay, fine, and that person as customer is trapped in your sales design. This means you are successful because your brilliant brochures, your beautiful publication, your beautiful propositions or PowerPoint shall convince that customer that this looks genuine, and because of trust developed, that person is convinced as customer and buys your product, and you feel happy that we have sold it. But when curse starts, you know that. When does it start? Sometimes it may not start even in many years, because in those days there was no quality system, but quality existed. And now there are so many quality systems and powerful quality systems with long books and long volumes and procedures and everything, but product quality suffers. Construction and manufacture are two different words. Manufacture generally applies to factories, to parts, to machines, to equipment, and to appliances, etc. That is manufacture. Where fact is done, factory we call it, where fact is done. We manufacture means human resources manufacture, or men bring facts, bring some material to factual use. And one is construction, which both are similar but bases are different. Manufacture is done in a factory, permanent factory, and this is done permanently. All spare parts are manufactured different locations at different locations, whereas you can say machine is assembled in one location. But in construction, every location is different, and that location can't be moved, can't be transported. That location is so powerful. In factory, there are various controls. People are generally on safe desks. Their workers are not prone to that much accidents because everything seems to be well defined in mechanical work, in other manufacturing work, in motor world, or you can say wherever is heavy industry. Generally, you will find that systems are established. So there are, but in construction, every new project requires new system, and new, you can say, approach to adopt and to run project construction, and this takes longer durations. Every project takes about a couple of years, whereas factory manufacturing is different. Everything is defined and daily products are delivered and daily products are produced, manufactured, and assemblies are conducted. So there are different kind of role in both factory role and you can say site role. Site role is much more difficult than factory role because nothing is defined for that site, and it is to be defined not by system but by temporary system, because once this site is closed, it's completed, that system becomes a record, history, nothing else. History record, you can say. So we have to understand this point of construction. uh, I know you understand everything about construction, but but you know but in a varying speed, in varying interpretation of construction of construction process, I want to share. In in our construction, what costs more, what is considered more valuable, it is time, and it is cost, and it is quality. We say time is in control of none. That is true. You use it or you don't use it. Time does not wait for anybody. It goes on and on and on. It goes on and on moving. Even if there is no work, time moves. It does not care for what you did. It does not come back to you. And it is directly related to cost, proportionally related to cost factor, because more time you use, more cost it is. Then you can say time also cannot come back, like cost cannot come back. Whatever is spent unduly on that, it's loss, because that undue factor has taken money and gone. Then comes quality. Quality, actually, if you apply after comprehensive understanding, I can assure that you'll save time and money. But people think otherwise. He demands so much quality. It will make me a loss because I did not consider all these factors during my working out bid. I considered practicality. I considered virtual world. I did not consider some person comes and it gives it as it. No, I want to see that way. Means it's a kind of a marginal sum that site contractor thinks I'm going to lose. So construction is very different. It's misconception. If you perform qualitatively, you shall lose something. I cannot support this statement. This is not right statement. This is a wrong statement. I can say that. So, what I say here, you have to, when I am convinced that my system is right or it's amendable and it's adoptable within defined criteria, whatever criteria I fix for that, I can say that, okay, it's fine. I must continue like that. My purpose of this small talk is about quality related to methods and methods related to quality. When I consider that people should know, my workers should know, my associates should know what is in my mind, what I want to do. You see, just by explanation or by verbal instructions, every aspect cannot be expressed. Because when I instruct someone, explain to that person, I take 10-15 minutes probably, and that person at that time would say, yes, I got it. But when I see practically that person missed it here 70% or 50%, and otherwise that person got only that much. And really that much is not what I expected. I expect that every act that person or my persons, my workers have to do, they must know all details clearly through supervisor or foreman or site engineer. And this should be explained, this should be instructed from time to time during process of construction. There are so many activities in every work: structural work, finishes work, preparatory works, temporary works, permanent works. All have processes, all have certain procedures, of course with variations, with alterations, because there are so many methods for one activity, and there are so many activities where typical methods can be applied. It depends on experience, it depends on conception, it depends on intellectualism of professional, how work should be done best. And that program must reach our workers through our supervisory line staff. We can say method statement or procedure is very specific term, special term, particularly for our people, but it's very common term in global environment. Those countries who are very serious, those companies who are very serious, they value statements, they value role definition, they value what you claim should do it. That's what's required. If I claim that I'm going to give you quality, I must do it. Use of that product shall tell user, yes, it is quality. That surprising statement, that surprising stakeholders understanding that what we said we are getting, and customers should say, yes, I got it. That is possible in manufacturing, but that is not possible in construction, particularly technology based construction, concrete construction, RCC construction, and other disciplines of construction. Because construction is not one day job. It can't finish in one day. It takes months and months and years, and what goes there, you do not know. You have to trust, you have to believe, and that trust should go to, or should come from, working of frontline staff, engineers, or you can say others, supporting people and concerned or involved working standard people like all trades people, technicians. If these people are trained, if these frontline workers, supervisory and otherwise, if these people are trained to upgrade their skills, which is also not easy, these people can do wonders if they are allowed so to do, because training itself is very, very cumbersome. Because I'm not talking of college training or university training. It's different type of training. It is different type of training. It is, yes, of course. This training says skill development for site engineer, skill development for project manager, skill development for tradespeople, artisans, skill development of workers, skill development of various others designations. There's no formal way to train them. They have to train themselves, and these projects will train them. They have to train themselves from update of literature. They have to train themselves from various other stars I say. They have to train themselves by refreshing their memory of studies, and like that, they have to train themselves from each and every viewpoint. And that training comes by virtue of good work, by virtue of acceptable work, and they can be trained by person to person. Person to person means in same family or same profession, one teaches others. Those who are experienced, they can teach lesser experience or others. That is process of training. No formal training that I can say, oh no, you join ITI, you'll get this. No, that training I'm not talking. That is also training, but that is very elementary training. We are talking here training that is responsive, and without which you can say nothing can move. So engineer who is experienced one, particularly civil engineer who is very experienced, it is a moral duty of engineer, it is professional duty of engineer to distribute knowledge to those who want to upgrade their skills. It can be written way, it can be video way, or it can be whatever medium is possible. It may be stressful, I can say. It is stressful, yes. It is stressful if you can do it. But it is also pleasing if you do it. You get my point? Stress and pleasing. Stress is stress only up to that time you don't get it. You don't energize yourself. If you get problem you have, you solve it. A problem which you get and you solve it, time you solve it, your stress is gone. You got my point? That stress neutralizes, or you can say that solution neutralizes stress. So stress finds solution and solution neutralizes stress. I have written, because of my job description, of a specific post, not ordinary post, that is generally called technological office or office engineer profession, or you may say coordination or coordinator or interface. Oh, so many terms are used for that. Those are very important points in construction. That construction is not just mean site work. Construction does not mean site work alone. Those who are leaders in construction or on projects, which may be sometimes EPC type, where design is also involved, and those who are in just construction, only difference is that design is not done in construction, it is complied with, while in EPC design is also done. When we realize this point, that let us just go for construction. Construction of what? You may say, I'm constructing house, I'm constructing school, they're constructing this and they're constructing that. That is project title. You are constructing from unknown. Yes, unknown means we are going to construct something which was unknown even to designer, and which is also unknown to you. Yes, you know drawings of that, you have specifications for that, everything you have, and there's a long process of controls that has to go on those. You cannot claim whatever concrete mix you are pouring in is tensile. You say, okay, it is 40 Newton, it is 35 Newton. That is designatory, not real one. A real one you know only when you test it after concrete is hardened. It's not only for concrete, it's for everyone, everything, except those materials regarding finishing items or other items which are readily available in industry, in factories, and we know what is their test values because these are already tested. We can say, okay, this is block 7, this is block 9 Newton, this is 7 Newton, this brick has this much stress, the style has this property, and this, whatever you can say, whatever material is available in the market, you can see this is this quality of that, and that is verifiable, and that can be, you can say, accepted easily. But here we produce at our risk. We assume that based on our trial mixes or based on our past records, this shall certainly have this, that's, you can say, kind of trial and error, and it's practice, it's method. There is no other method that we can say, no, we can do that. No, you have to go this way. There's no other way around. We have to go that way, and that is an only way. I can say that is an only way. Otherwise, there is no other way. There is no other way out. We have to go that way. So we say method statement has to be developed. Who will develop it? Question is that it must be in expression. It must be in approved format, or you can say affordable format or convenient format, and in a way, in a sequence that you pinpoint, or you can say bullet only that which is most important for reference. You see, method statement does not mean, yes, it is written in a proper way, but it doesn't mean you have to read word by word. You have to refer to it. It should be a document, a kind of resource. You know, books and resource, we say. One is book and one is a resource. What is difference? Book is textbook or book where you can say that certain syllabus is complete and this suffice you, your requirement. You can pass this examination. It's okay. I can pass this examination. But the resource is something else. This is permanent. This is not a year pass examination. This will be used even after 50 years. This happens. Reference books, we call them. We call them resources. And this statement which you are going to construct for this project or activity, that is called method statement, would work for you as such. Of course, you can edit that statement to customize new requirement, but contents of that statement do hold good. So you have to develop a potential to generate method statements yourself. And remember, method statement is a must. Even if it is not defined, even if it is not conditioned, yet it is a must. Because proven written statements give you better explanation or instruction indirectly, virtual instruction of what you have to do. And if you find that what you do can be more better, then you can amend the statement. Not for you, it's for those who require your knowledge. Others will read this and they will like to make sure, yes, you are doing this way. Once there is agreement that we are going to this. That's the important point here. Why I'm stressing a method statement, that is the only reason. It should be in expression, it should be in format, and it should be for performance and define performance. It's not simply that way, so you'll get this. No, you have to define. You have to define in sequence. How shall I get it? Based on support of material, based on support of drawings, based on support of codes, based on support of, you can say, past experience, all that. And you can refer to some project experience also if you wish. And there we can say, we just take out from those statements redundant explanation and just put point to point so that message is communicated properly to site line person who can easily do this or implement this. That procedure, that method statement, you must understand. It's not easy because you have to write something in 2 or 3 pages, not in book form, but you can talk a lot on that. So whatever you talk, whatever you learn, for something to be done, you may have to follow some other's statement or your own statement, which others may follow. This is expressive thinking I'm giving you, and because this constitutes formation of quality, and that quality is very, very significant in construction. Every material that we get in construction, or even same material in different batches, always there is variance on quality. That quality variance is also known in our world. That's known. And we accept that because there is no other way. And that's the reason that degree of uniformity or mix of concrete material or other materials varies, is within acceptable limits. And if there's a drastic change sometimes, then we have to redesign that material. But it takes time, and time cannot be recovered. In beginning, it seems that we are using this time for this, and we are spending cost on that. Yes, that cost is a must. You have to spend cost. If you don't spend cost, you can't regain cost. Cost once spent, and if you are successful in that, that procedure shall be adopted by you for all such activities, and which will save you something. You may call it your cost spent on that formation mechanism, that construction mechanism is indirectly back. No escalation has been caused, and risks have been prevented because we knew these risks, and we tried to find solutions in advance before risk came in. And as you can see, risk is no more risk now, it is solution. And maybe you can see that this is a kind of, you can you can say it is kind of sub opportunity, and additional small opportunity to create more and more statement. This means one method gives you another method, and then give another method, like that. And that is where we consider these factors, and that's why I'm saying reliability, that you do something and it is reliable, then you do it again and then it is reliable, then you do it again, it is reliable. Means reliability means equal to liability, reliability, then reliability, like that. You have made sure that whatever you did is safe, and whatever you did is serviceable, and whatever you do is durable, because durability is important in our world, construction world, design world. If you just think of safety, and if you just think of service ability by that use of material that we produce, and we don't care for durability requirement, durability criteria, we can simply say we can't calculate life cost, whole cycle cost of that material. Today it looks fine, it's safe, it's performer, but if it has no life longevity, if it is just finished in 2 or 3 years in place of 40 years or 50 years, this means you are going to lose. But if same works for 50 years for me, by whatever way, well, I think it will reduce my cost. Got my point? You can take example of polythene, example of plastic. What happened? Why we are worried? Because we use this material without understanding its thorough nature, its thorough structure, and we try to say, okay, use it and throw it. Though it is not decomposable. Even if it's not decomposable, it could be designed in different way. If suppose some item is, some gadget is useless after 3 years, we say, okay, throw it, and we take another one. You have money you can take, but that loss which have caused to nature, who shall pay for that? You have thrown it, you bought new one, and you say, I got new one, it's updated one, that was obsolete. Just considering your obsolete nature of that material, you decided to discard this, write off this. But you forgot that this is going to result in pollution, and it resulted all over the world. If it had been usable for 50 years or in repetitive way, for example, I take polythene bag, I say, okay, I got this, I bought this metal from market, this product from market, and then I take out that product and throw that bag outside. Oh, this is no use. I'm not going to use it any further. I throw it. You know this is very dangerous, but people do it. Throw it, it's no more useful. It's no more useful, that's okay. But why it's not useful? Because you did not understand that You thought, my use was only to bring that material as packed one, and purpose of this bag is over. Right? That is where danger lies. I always stress people to use quality, be quality user. If you bring a bag from market, though it's not recommended, even if you bring that one, try to use it 10 times, 15 times if you can. Only your procedure is, your requirement is that you keep it safe somewhere. After its use is over and you think that it's workable, work it, use it. In next activity, in another activity, in storage activity, don't throw it unless it's beyond your control. So if same bag is used 5 times or 10 times, first of all, you are going to use that bag. It's giving you back its cost. And of course, when it is used 10 times, its life is used. If you throw it, there's no use. It will fly due to wind from one point to other point, all over, all days. And you'll say it's pollution. But you forget, you created this. Nobody else. We created ourselves. Everything like that. So we have to pay for that, if that is creation. Really, this is very important point. So here cost impacts. How does it impact if you use same material for 10 times, 15 times? If I mean to say 10 times or 5 times or whatever number of times, if you use that bag, at least more bags won't come. You have used one bag if you use 5 times for 5 activities. Otherwise there will be 5 bags or 10 bags. It's a very common example, very simple example. And also, first of all, it reduces risks of new plastic pollution. And because this bag is reliable, it has got certain tensile stress in that. You'll say, what I'm talking tensile? Yes, I'm talking that. Elongation and tensile strength are properties of this material, polythene. It has elongation, many hundreds percent. You can say unimaginable percent, you can say elongation it has. And it has also some tensile property, tearing property, like that, which you may not realize because you don't know how to do that, but it has. So it is reliability. If it has a strength, it has, you can say, elongation. It can't burn, but it can be useful. If you go to any place in world, whatever place you go, whatever country you go, even developed countries, you'll find pools and crops of plastics everywhere. And all that is, we could not use it. We did not understand durability of that. And we threw it because we don't cost it, we don't mind it. And that's where I say we are responsible ourselves to cause this harm to ourselves. Nobody else caused this harm. Now, when I talk of quality every day, I feel pleased that something is coming to my mind, and that something, it can be automatic or it can be with nature support, God support, that something comes to my mind. And what is that? I have to understand that property, to find out intensively, find out with full involvement. You can say each and every point, each and every member of that view which comes in my mind, I have to understand, and that's called a kind of analysis, which is, you can say, very significant part of engineering and life. Analysis is something, it doesn't need mathematics. If it's mathematical analysis, fine. But it doesn't need mathematics. It needs your essence of brain intellectualism. What level your brain has been intellectualized, and to what level it has been, made to be used for that. it has made for use of intellectualism or research. You can say operational research. It should be done. Nothing wrong with that. Analysis, again I say, I stress, is that part of life where first of you think yourself, forget other analysis. Did you ever talk to yourself as an engineer? Did you talk to yourself, or you are just all time behind? One has to talk to oneself. Of course, you will not speak, you will not take something, and you laugh to enjoy nature. But here is not nature. Here is your mind. You sharpen your mind, and sharpen your mind, and think. I understand that analytical study is no less than worship. Is no less than worship. Because when you work with the persons, you can say, my God gift, I should say God gift, is for everyone, and that is thinking. Thinking. So there are some people who run away from thinking. Wait, I'll think. And that person another thing. Other people who considers thinking as professional is religious, because thinking helps you. Thinking brings you out from unnecessary tension. Thinking is that part of life. And in engineering, I think thinking works at every step. Every step. Think on. It's not verb. It's not verb. It is whole world. If you break this word, it's a THIN, thin, and KING. Can you understand that? What does it mean? Well, that was just article of this. Now, we say engineering. And engineering means application of sciences, application of physical sciences, other sciences, application of technology. Right? That is engineering. Engineering, and this must be achieved. When we say that engineering is advancing, what does it mean? I say engineering is not advancing, your thinking is advancing. Your understanding of materials are advancing. That is advancing. Engineering is use of mind. In fact, if you define engineering straightway, I would say engineering is use of mind, because it's not only reading or writing, you have to analyze that material, is to understand what is theory of that. You can say how is water, milk, and others work together chemically. That's the way of engineering. Though that's not a product of engineering, but engineering says that. When you think of me as if I am your member. So if you cannot confirm your activities, your work, to define requirement, I would say define requirement. Say quality non-conformance product is called substandard, and therefore we reject it. Engineer is either careless or engineer is yes. When we say engineer is ignorant or fake, careless, how do you think? You think or you don't think, but this is also fact. Very much fact. Now, I actually I have taken time to explain COVID. I took something in that. And again I say, in methods we use HSC. In methods, when we write methods, what we use, actually we have to understand that also. In methods we use signs such as HSC engineering. Actually, contents of method statement, if you leave behind scope of work, it starts with safety. Safety, health and environment, we define to some extent brief, though safety is available in safety plan. We cannot simply write that, refer to that plan, because nobody has time to refer to that one during construction stage or during 1 day or 2 day of construction. Now, we have to define how shall we maintain health, safety and environment on this activity or on this project. We have to define that, and it's part of HSC. And we have to define before HSC definition. We have to define what materials we are going to use and what drawings or whatever relevant parts. We can say safety involvement on method statement, particularly on that statement, which specific one, which is not very generalized. We should not only sometimes write about safety on that, but if it is complicated one, we have to make sketch and attach to that also. If it's not complicated one, nobody will question why you did that, because it's job. Safety, particular people also are not clear. My talk is not only for juniors or seniors, it's common one about method statement. Because you know what shall happen. If site engineer can write method statement, I'll be happy with that. Otherwise, no problem. Quality guy can write, or construction guy can write, or engineering guy can write. But what what executive people do on site, we have to discuss with them for composition of matter statement, or else there is no meaning as such. You may say, how to explain to our people what they have to do. Once time you have to supervise them, you have to guide them. I think second time they will understand what you want to do. They understand your statements also. But because you ask everybody, yes, I understand. Maybe we know this is only partly true, partly false. If they think telling out the education is not good all the time. Well, you have to move further on this. Again I say, how to reorganize frontline team workers in such a situation where there is a problem of working and sitting together, working in adjacent groups of 2 or 3, because you have to maintain safe distance between 2 persons. This distance should be appreciable, it should be reasonable, logical, and activity based. I am sure generally our workers will be affected due to this. First of all, wearing mask is difficult, but they have to wear. Wearing goggles too is difficult, but they have to do that. Likewise, there's so many activities which happen daily and we forget it. How to recognize frontline teams in such a situation so that all workers remain safe is a big question. And it is responsibility of entire engineering professional community, entire community, I'm saying it includes electrical, mechanical, and all others who are involved on our project, to contemplate on working issues, right, working issues that would be impacted upon due to additional protective measures required to keep off this ailment or this pandemics. It's very important part, no carelessness. Many activities are critical in a sense which do not permit maintain social working distance, as well as cost and convenience wearing all PPEs full time. Distance between 2 persons and all these processes of nails taking out. You know, social distance as well as cause inconvenience to people wearing PPEs full time, wearing, overalls. Such activities where it's a must, all these are a must be analyzed and thought of to resort to safe actions. Maybe output affected on such activities, but health of workers being more important than output. It may happen in one case or two, but once they come to streamline, when come to use of that, it will be fine. Workers must be allowed additional pauses to maintain physical equilibrium, keeping abreast this pandemic's COVID-19 impact on combination with high temperature and variance in humidity. You know that high temperature and high humidity, these are supporting circumstances for virus to develop. Now, certain facts. This is already I told you that when I said that all activities that we do on site must be done in ventilated environment. Must be. If it's weather like rain and forest and forehouse, all these ventilation. When I say, it doesn't mean that you have to put extract fan there. No. Fresh air they should get in normal working, and when there is no normal working, for example, there is construction of some shell or some silo or some tank, big tank. After these walls of tank are over, foundations are over, walls are over, you have to work in that, and sometimes your top cupola is also over. How people should go inside the work, and when they work, what should happen? This is very much true part of problem. We have to contemplate many heavy construction activities may require forced ventilation too, or other inputs for workers which engineer have to contemplate. Now, these are all problems I'm showing to you, but I'm not going to that much. I'll just give you that I was regarding COVID-19. I learned that more than, you can say, 2012. Doctors we have lost, because there might be some left somewhere. In our world of engineering construction, there might have gone to such scraps and dust, all these materials. We can't name now, we can't give evidence now. But this doesn't mean you shouldn't panic. Quality and safety are such relations together, that without safety and without quality, survival is very, very difficult. Very, very difficult survival. We have to consider this point clearly, that survival is difficult. So now, because I've been involved in my thought to share with you. I do not claim on my thought. It's not wonderful, it's not, you can say, exclusive one. But whatever I think based on my small experience and what I consider is better. Maybe you have better ideas than that. but I'm sustaining myself. So I'm giving you some imaginary views, imaginary talks where I feel a good one. When I start quality checks, it looks as if it is something extraordinary. I also used same in beginning when I did not even start writing in newspaper. I have listed out certain quality check statements which I am going to share with you with explanations, of course. I'm not saying everything is fine. Everything is fine only when it is fine. I am going to share with you these statements, and these are very practical ones. And I like to share with you that with certain sketches here. Of course, now I'm contemplating on you can say let me close some files possible. I think a quality file no noise discussion quality. Keep it safe. Yeah, I think I should. It's better I close this one. Oh, safety is also there, so I can't close anything. Let me open this. I can say some records of my. I'll say what to do with that. We say I find methods. I think not skill development is management. Foundation forms, sketches, safety, where is safety? Please hold on, please hold on. Oh, I'm going to show you certain sketches here. Now this is a sketch here. You can see it's ordinary sketch for some ordinary trench. Which dimension you can assume is in sketch here. Trench excavation safety, what you do with that? This is say 3 meter by 3 meter. You have to work in that. First of all, people should not fall in that. They should have some warning or some. Of course, no railing can stop them, but if they know, if somebody knows that there is some sign, there is some, temporary railing around, should understand that they are working there, and there is no way, it can't be left to public. But even for workers who are in the same area, they too are subject, they are prone to accidents due to that trench. Depth of that trench can be anything, it can be anything. And here is section, let's say I taken 2 meters, 2 meters depth here, and there's rail type, you can say that is here. This is what I say. This rail, you can say, is called safety post. I have put railing around, temporary safety railing it is. Posts are here. This is enclosed access, where some area is available for access into this, and there's a ladder here. If it's more than 1.2 meter, 1 meter, we require ladder because we can't jump. So this is a ladder of aluminum here. You can see in this range, it's a small one. So what do you actually need for this? We need, if you want to excavate that one, we have to do this way. This is trench excavation. You can see that one. This is a trench, and drilling around, you can say 2 meter depth of trench and 1.2 meter depth of or height of railing. This is very much practical one for ordinary construction, and this system you should have on site before doing everything. This sketch one here, and I'll explain to you the sketch also. As you can see, this is of course safety related sketch. Excavation safety of a major building project with ordinary foundations. Excavation safety of a major building project with ordinary foundations. I have named it sketch 2, and this is typical section applicable indicatively to all sites. This is what it is. You can see this is applied. I just said the 100. Keep it better. So let me see. Yeah, this is sketch here. You read yourself what that means. It's portion here of building where you have to work. This is building area, and there's safety provision here around. You can see that. And these are fence posts or railing indicatively. This complete railing around, say 1 meter away, or as is practicable for circulation. This excavation is not mass excavation. It's not that one. This is limited excavation, and we can say continuous trench. This says 2 meter to 3 meter deep. For example, you can see this is your foundation portion here. You have to excavate and keep safe like this. You have to excavate and remove excavated material simultaneously. So when you are on site, you will find this trench available like this, and this is earth area. It's also earth area. This also earth area, and this also earth area. You have to you have to make sequence which way you have to go, so that your truck to remove that material and your excavator are not impacted upon to position themselves, and all areas should be taken like that. But once you cleared that, you have taken spoiled material to stockpile area, and you fix this safety rails around. That's basic requirement, because I say trench is deep, maybe 2 to 3 meters, and width is of course natural. This whatever is are not written, but depends upon your design. And this ladder here, these are all locations of ladders. I put this location, this location. These are locations of ladders, and this dimension that are used in this 50 meters. Let me just blow it up again. This is 50 meters here I used, and this is very important one, very important one, and it's very important one from this point of view, that point of view, which you can say is important one, and I have to sense it accordingly. This sense is very important, and we have to think about this in a professional way. It's very professional. We have to think this, and what is this here? Why is calling this Good was calling. I don't know what reason for that. Who's this?
Good morning.
Good morning. Yes, how are you? Hello.
Right.
Hello.
Uh,
What do you want to say? Hello.
Hello.
Yeah, I'm not hearing you. Hello.
Uh,
Hello.
I want to speak.
I'm okay. Tell me what you want to say. See, tell me something. I'm busy on video. Tell me something or why?
Okay, okay.
Okay. Necessary, yaar. Khama kha yaar. See, okay, this was somebody called me. Chaudhary Rajo. Good morning, Mr. Chaudhary. Namaskar. Very good. You came here. Okay. Tell me more. What more? I'm telling you everything. Okay, now. So I was telling something about sketch and it's gone missing. You see. So what I said that's 50 meters here, 50 meters here. You can say this is, and 2 to 3 meters deep. This is here is 30 meters. If you can say this is 30 meters here. Approximately the size of building is 50 meter length and 30 meter other ways, and in between this is because 2 here is 26 meters. If you take 2 meters direction here and here, so it is that way. uh, when drilling fixed, provide warning tape in day, warning colored lights at night, and these ladders that I have shown in this range are located not more than 8 meters distance. 8 meters. 8 meters distance maximum. You can say from here to here to here, and can be lesser to 8 meters, not more than 8 meters. This is a standard because 8 meters means you have to walk about 12 steps you have to take in 8 meters. One step you take in 2.5 feet, you can say. About 12 steps you have to take, and nobody wants that you walk, spend time in walking rather than working, because you have to walk and then you have to ascend on this ladder, and you have to again come back and come enter into trench and come out after walking. It takes plenty of time. Therefore, keeping all these factors of time and cost and number of these ladders, which are very expensive. One ladder may be many thousands or many $100. So you can see in this how many ladders are there. Just see, I put it. Doesn't matter that one, but let's see just how many. 1, 2, 3, 4, 5, 6, and 6 and 6, and at 18 is 12, 20 here, and you can say 21, 22, 3, 4, 5, 6, 26, 27, 28, 30, 31, 32. 32 steps. I'm sorry, 32 ladders in this. So it's expensive. 32 aluminum ladders we are using in the system, but we are helping our workers. I could keep at 20 meters also, but that won't work. Yes, better you keep. You can, if you have big projects, you can use them. This is safety measure. Your people should be safe. Safety is requirement here. So this is purpose of this sketch to show. If you see here, this section here, this is 3 meters down, and you can say this is strange, like this from here to here. I just put in, and these are steps. I mean to say, these are here. Is your these points of post. We put this railing around, and this is trench, and in trench like here you can see that I have put these positions of ladders, and excavation safety of a major building project with ordinary foundations, and I named sketch 2. I think you got my point. I also written when railing fixed, provide warning tape in day, warning colored lights at night. Warning tape in daytime, and warning lights in night time at night. Means this portion is not excavated. Just keep in mind, only trench portion is excavated for substructure activities, and this is clearly given 46 meters, and this is 50 meters. That's why it goes like this. I just indicate you, means this is not warranted for any site. This is only for explanations. And let's take, just like I said, this is sketch 1. I showed to you before. Very ordinary sketch of one trench. And safety posts are there. You can say these are safety rails as defined here. And this ladder put in here. And this can be done like this. So I'm just closing this file because I can't keep this files open all time. So this I close here, and I go to another file which is also for excavation, and it is yes, this organization chart. Let us see. Okay, see this one. This is another one. This is you can say. I'll keep on showing this sketch again and again. This is, you see, there's excavation safety of a major building project with benching. Typical section applicable indicatively to all sites. Generally applicable in clay and silty state strata. Again I say, excavation safety of a major building project with benching. And excavation safety of a major building project with benching. Typical section applicable indicatively to all sites. Generally applicable in clay and soil, silty soil. Well, if you see plan first, this is plan. I think I should use this. Yes. I think you are comfortable in viewing this. This is, this is a area. This is area and this is area. It is foundation working area to be dry. It's written just, I'll blow it up and show you. This is, foundation working area to be dry. Means wherever we have to work, that should be water free. Dewatering system not shown on plan. Okay. Safety rails on lower benches not shown. Well points shown in one layer only. Well points to suck water from strata. Header to receive sucked water from wells. Header to discharge to manhole through hose. Yes. I'll go back now. It's a big trench now. If I say dimension wise, this is 50 meters here. You can say 50 meters here. And this is the dimension of this, including benching, not internal. And here also it is how much? I think it's 50 meters. So it is 50 meters square. Quite considerable. This is 50 meters square covered up, but real working area is lesser to that. And this is because we have nothing in surrounding, or we have space available for easy understanding. Now I want to go to this trench. You see it's excavated, but when you start, it's not excavated. We are just trying to tell you about safety. That's why we assume that this is excavated one. This is that section and this is that section. Two sections are there. This is longitudinal section of this, and this is cross section of this. Both are there. You have to understand each other. Now, first of all, let me explain to you in plan of this what this is. In plan, it says ramp, ingress and egress. Ramp is shown, and here is ramp. From ground here, we go down, and these lines are gradient lines, slope lines. When we show like this, it's slope. We go down and come into this area, foundation area. Means whatever depth be there, you have to make some ramp for trucks, for others, because for people there are ladders. So it's only for transport, heavy transport, shovel, excavator, truck or whatever machine, and even concrete pump, which you can say, possibly, though we can do from outside also, no harm. And for convenience of all this, these are done. It's a ramp location to be decided on site depending on your ease of working, and width is 4 meters to 6 meters depending on requirement. This is width of ramp 4 meter to 6 meter because your vehicles can come in. That's the purpose of this. If this is available, if this is suitable land for this, then this is if required, the watering to be done. If required, the watering to be done. Well points to be installed around, and trench base headers and miller pumps on ground. Trench base headers and well point is done. Well point is installed around this, and trench base also is headers are connected to well points, and those headers are then finally connected to very heavy pump, which was known as miller pumps on ground. So this is a system. I'm not saying you buy from miller only, but well points are inserted, and these are connected to 4 inches header, which is of course connected to sisters accommodation, or what you call it. Then here is trench. You can see these benchings as I showed to you here. This benching, I'm talking of this benching. You can see this benching. Excavation, safety of major building project with benching. Typical section applicable indicatively to all sites, and generally applicable to clay or silty strata. Why I have noted this is a point in that. Clay and silt are two very different soils. Clay is, thixotropic material, and it is very porous and also not permeable. Maybe these are technical terms for everyone. So I also need to explain this also during my talk, and that's what I'm doing, trying to explain to you about this. What is this clay and silty soil before going further. Because if you do not know, you will simply say, why is it so about clay and silty? First property of clay is that it can sometime stay vertical, or you may say there is question of angle of repose doesn't work there. Sand is different, it's reverse to that. Sand can collapse. Chances of collapse to clay in excavation are rare. But this doesn't mean that it's stable. This doesn't mean that. Clay, is a soil in which there are pores. Pores means small holes which can contain water. which can contain water in its body, but that water in voids. Voids means where there is air but no material of soil. In soil itself, these pores are called pores, voids. These can contain water in them, but because property of clay is that these pores cannot be connected for flow of water, water present in clay in pores cannot move from one pore to another pore immediately. This cannot be done. Another property of clay is that it cannot move water within this. That's called, it is not permeable. But sand is permeable. Voids of sand are linked together for purpose of movement of water. In clay it does not. Clay has different property. When it contains water, it can swallow. Swallow. That's a big point. Means swallow. This is swallowed volume. Maybe it's x volume. And swallowed 3x or to x cube. It can. Well, this talk is not for properties of clay. But I'm saying that if you work in clay, you have to excavate. You have to put installation of dewatering system. And this is benches. Total depth this year, I think, let us say how much is this. That will tell you how much depth it is. You can see this is 9 meters here. This is ground. This is ground. Here it is 9 meters up to here. This line, this one, and in this portion only we shall work. Here is another one. This is called benching. This is benching, and you go like this. This is benching, and this is ground. So on these levels, I have put dewatering system. Well point system. You can see this is well point. This is well point. This is well point. This is well point. Well point means when I say well point, I am actually, this is well point. This is well point. This is well point. Same way, this is well point. This is well point. This is well point. Then these are headers. Headers means pipes which will communicate water from here to there. And that's very important part of that. That water we have to contain in, but understand that. Why these people are just calling for nothing. Oh, fuck off, I don't want to talk to this one, leave it. Okay, then this part is very important and says that this is excavation level. This is excavation level, and this level is well point. I disturb you for the thing. This water when flows up because of pumping, this flows up into this well as a filter here down. If this filter does not allow clay particles to come in and water freeze, sucks up, moves up, and enters this header. This header, which I think is shown somewhere here. This is shown here. These are well points here. Only one layer I have shown. These are well points. And this line which I am moving on, this here, this is headers. This, these pumps are connected to this line. You can say, oh, maybe some drawing error, no problem, but these are connected to this line. 1 meter spacing of this header. This well by 1 meter, like this. These are vertical pipes that I am showing you here. These are vertical pipes. These vertical pipes are here. And this is connected to header. This is connected to this header. And not in one section. This continues, this continues like this. So the water from all is called a ring, you can say. Water from this normal ring is through Miller pump or suction pump is taken out. And this is one layer only I have shown. But if you see one layer, second layer, third layer it is. And that's where we say this dewatering is done continuously. continuously is done, and then install here one, and we go to excavation, another one we do here, another one we do here, and then we can say this goes on, and until excavation is over and foundations are over, all foundations are over, we come up to this point, then these well points are removed. This I'm talking of well points, I'm not talking of sand soils or submersible pumps. It also values good for that, it holds that. Here then we can say, here is a pump here, this is benching here, benching is well points, this is benching, and here is that header, this is the pump. All these three are connected. This diverter pump here, and from here you take it to public manhole. Here see where manhole is. You take to public manhole and dispose it. This is sole purpose of this well point, but our purpose is not well point, our purpose is safety here. If you see elevation of this safety railing, you can see I put railing here on this trench. This railing here, and of course a standard railing as usual, so people should not fall on this. Maybe 1.2 meter probably, it's not clear, so it doesn't matter, but 8 meters are here. These are ladders, and this is only for purpose of this. Put everywhere, here, and as you think is safety should be maintained, we can do like that. This is safety railing, these are ladders here. Excavation safety of a major building is written. Excavation safety of a major building project with ordinary foundations. Typical section applicable indicatively to all sites. Typical shown only for railing. This is excavation safety of a major building project with benching. Typical section applicable indicatively to all sides. So it's now. And here is a lateral location not more than 8 meters, and you can say this is what I explained to you. You can view it, no harm. Viewing is also important. Let me see if I can put my feedback to them, and let me give you also another sketch if it's possible. I can give you another sketch if possible. I'll back in minutes. Okay, I'm back here. Fine. So we can now. I was talking on this issue that this is benching, and I explained to you what we did in this. Water is pumped out, and this excavation safety that is more important. And also, this is sketch. I put off other sketches. I think I can't open these all sketches, so I put this sketch and this sketch off. Why both sketches come up? I don't know. This is sketch, okay. That is I keep it off. This is here and this is here. The same as working it with dry dewatering system not shown on plan. Safety drills on lower bench not shown. So this is same thing. So I it is also sketch 5. So we can say, okay, well point system explained to you. So I put off that, either of them. So let's 5. Let's go this also and go to another sketch. That is here, which is okay. This is also important one. This is this is sketch which is showing you here. This is section support to structure surcharge during excavation. Here, see this in excavation here. Let us say 2 meter wide, 4 meter deep, and this is surcharge here. Here, existing building. Let us say existing building, and whatever it is, 3 meters by 4 meters, just for example, and this 4 meter depth. I have to put, some support to resist this building as much as possible in this trench, which is already excavated, and we have to support this, and that's called support to surcharge during excavation. And this is surcharge, and this is guardrail, this is ground, and that's then also same existing building. It's 2 meter here, 4 meter maybe. So this side we have to put both sides. Also both we see. We can say additional supports here. Also same way, ground level guardrails, and it can be support during, and also it brings even more, right? So if it's small one means there was 2 meter and there were 4 meter. So we tried to link both things. So to resist this is here, and to resist this is here. But here there's no resistance required here, so we just keep the supports here, additional slanting supports and support to surcharge during excavation. Simple, you can understand that. Then we can go to other one, that's 7th, and that is here. It's here means you can say this is not for excavation, this is for scaffolding work. As with scaffolding, I say to you, it's required every year. Access is required every year. So I can say now I close off this, and we close off this. I was now talking. There's so many sketches I showed to you regarding this excavation that I talked to you that day. You can see, I can repeat, I can read again if you wish, and that is here. Reading is important and learning is important, so that you can say it was checklist and ITP. This is inspection and test plans for indicative guidance only, and it's checklist setting out and excavations. And this I name item number 1. You can name whatever number in your own list. You can schedule out your own list. It doesn't matter. Now reference is to project key plans. You have all key plans with you, all detailed plans with you, a relevant one. And if it's for individual building, you have individual plans for that and for coordination purpose. Now grids calculations in all directions be ensured. This is very important one. People may be confused with that. What are grids? Do you know what are grids I'm talking of? It's something you chart out, you make a graphics on your plan, x, y axis, both x axis and y axis, and you can say this is my grid. I can explain to you. Well, maybe just a minute. Let me see if I can find that grid. This is also possible if we can talk of that one. Let us see if I can find it from my own method statement, and I can say explanation is sometimes very more important here. And, before that, what math sense is a house, this house. Okay, this house, and this is yes, this is grid. Let me show you this grid. Okay, this is foundation, this is that. All right, I'll show you this grid now. Yes, this is an architecture I'm showing you. No, it's a house plan, and I'm not going to detail out this now, but what I'm trying to show you, this is, for example, basement, storage, and this x-axis, and this is y-axis, vertical, horizontal. Here I put some axis of these columns. This is axis of this column here as well as this way, like this. This is known as grids A, B, C, D. 1, 2, 3, 4, 5 likewise. You can do whatever you wish. It doesn't matter. Purpose of this is to show cover up, means to control our work, because this is just nomination. And in addition to this, we can also name these columns. It doesn't matter, but even if you don't name these columns and these beams, it is already named. Example, say this column I want to name. This is B and 2. Simple. If you name C1, C2, C3, C1, C2, it's a B2. It is C1. It is D1. It is here. For example, A3. What's wrong with that? This is direct graphics understanding, and we are engineers. Means we are not kids. For example, this is here also when I say grid B. For example, this is B5, C5, D5. What's wrong? What's in the coordinates? I don't understand them. This is grids. Now I tried to show you that, and now I put it off also. Then we come on to where's that? As I was talking of this. In this also I take one more, and that is, there was some sketch here, and that is sketch 1 I have shown to you already with this sketch, and then we have this execution safety. I'll show another one. Raft. Okay, raft, and sketch 4 is this. I guess sketch 5 is this. Then I'll show you raft. This is that sketch of raft. I'll view it differently. And so this is the raft. It says this is raft here. You can see this is raft here, 50 meters this way, and let us say 30 meters this way, just for indication purpose, and this is elevation of that. So this is 50 meters here this way, and 30 meters this way. This is excavated, and this is safety rail around. And because there's no benching in this, this is ladders here, and this is ingress, egress ramp for heavy vehicles equipment. This location to be decided on site depending on orientation of site and communication or circulation of your vehicles you want to do. This width be 4 meters to 6 meters depending on requirement for your transport. You may take trucks in, machines out and trucks out, or whatever way. And this is not generally meant for people. People have to use these ladders because we have to avoid accidents also, because bank of flagman is here. This is entry. There's no ban to public entry or people's entry, but in case when transport move here, excavator, trucks also they work here, or other vehicles work here, in that duration public movement must be avoided so that accidents are prevented. That is made purpose. Otherwise there's no ban at all. That's why, it's like that. This is, if when railing fixed, provide warning tape when warning color lights at night, and if required, diverting to be done, well points to be installed around and trench base, headers and miller pumps and ground. And this is your railing here in your elevation or longitudinal section. And it's given excavation safety of a major building project with ordinary or raft foundations. Typical section applicable indicatively to all. This is depth of that excavation 3 meters. This is 1.2 meters railing and trench by mass excavation. Mass excavation means whole area is excavated. We will not start. How will you start? This ramp is there. You have to start first on ground, then as depth goes up. Once you can start from here and goes down. From here you can start, and ramp is also built at same time. First you have to build ramp and start excavation. You do this so that this all area is covered up. The excavation and our trucks may come up to here, and go out or there. If you want 2 ramps, 2 way also. It depends on site requirement, I say, because 50 meters movement of truck is also expensive. If you have chances here, and it doesn't cause any problem in your raft, you can take here also. But in whatever way, one is essential. Depends on how much you see. You may take one diagonally here across also if it permits. That's all permit. And this excavation quantity is mass excavation. For example, 50 meters by 30 meters and extra 3 meters. This means 50 into 30 is 1500 into 3 is 4500 meters work quantity. This is. And then ramp. And maybe this is not exactly same. You have to excavate more probably. Or if it's 50 meters only, then maybe size of building is wrong. But 50 meters into 1500 into 3, 4500 cubic meter. And maybe some cubic meter here, you can assess yourself how much work you are going to do in that. That's an important point. And then I can say, if I see then sketch 4, what is that? It's already done. Deep excavation, that we have done. Deep excavation, trench support we have done. So all this PR foundations. So okay, then I should come out of this because this is over. So whatever purpose was this, I'll given to you. This one, I close this and set. Other one I say. So that's what I said is purpose of this. So you have here grid calculations in all directions be ensured. You have seen grid plan, typical one, and that's where we have to stand, talk. This is grid plan. Also this grid calculations you have to rely on before you start your work. You have to make sure that center to center distances or whatever other measurements are given, these tally with main dimensions are given end to end, overall dimension, and the sum of grid dimensions must tally. If there are angular measurements, that must be worked out and checked. Level profiles conversion from GPS definition, I have seen this, I talked earlier. whatever horizontal controls and whatever vertical controls, those must be affected on site or established on site through GPS, through third party probably, which is more reliable, so that they have been certified that. And coordinates, which is horizontal controls, are coordinates converted from real coordinates to plant coordinates. So plant coordinates, real coordinate that you make sure. Your coordinate, whatever you have, is more important because reference coordinate you have that. We convert sometimes, we don't want to give plant coordinates to contact because of some reason. So what we say, we convert those coordinates to site coordinates. You can say working coordinates for site, and plant coordinates, for example, it's fixed 100 or some other. We say on site, this is your coordinate. From this you can take whatever you want to take. So it won't make changes, dimensions, but it won't change coordinate values, coordinate numbers. Same thing, level can be fixed. How from this 00 level you can take your levels, and that 00 levels is this in GPC, it is written somewhere. Same things like this coordinates are written somewhere on triangles or somewhere else. So level profiles conversion from GPS reference and coordinates converted from real coordinates or plant coordinates. Third party certification is very suggested, very much suggested, but it's not mandatory. You can shift levels your way. If third party is there, maybe that party is expert. It's better for you. Setting offsets from building lines for zoning, that front setback, rear setback, side or this side setback. That is according to plans. I can't change that. Or soil investigation, very important part. Whether it's very important part in the fact that without soil investigation, sometimes soil investigation is very important. And that's the question: is soil investigation report available and well studied? That's point. Soil investigation report. If you have that one, because it's a considerable soil, spend money on that one, you must study that. You must have a conversance with that. It must be, or else it's a problem here. Just keep, I'll be back, I think. Soil investigation report is very much important. If you have that, study it before doing everything. Don't touch site until you go through that, because it's technical report and it can be understood only by technical persons, well experienced, well engineers. And soil report gives you so many parameters. It shall give you forget history and forget location. It shall give you what method were used, investigation, borehole logs, bearing capacity, can say many electricity resistivity and thermal resistivity, and many more parameters it is done with. It's certain on that. So you go through all those reports and understand them, because whatever you're going to reach, and that in design and how it will impact on your work. If it is soft rock, or it is soil, clay soil, or it is sand soil, maybe limestones, or moisture content, or not moisture content, dewatering or no dewatering required. You shall know that from report, and what technician or designer suggests there. What should be your bearing capacity, or what should be shear stress, and what level you have to keep that, and what are other precautionary measures, or soil improvement is required. All that you have to read, because in many cases soil improvement also works. You cannot just say it for granted. That is not for granted. That is requirement. This point of soil is very important. You have to go through study the logs to understand, what logs speak and what your plate load bearing speaks, how much bearing capacity, such as if it's if it's your sandy soil, or if it's not sandy soil, what else this log says. And if your design meets it talks in the same way, it's okay. Or you have to raise some case questions. And also that what is RQD value, what is N value. N value is very important, RQD is very important. All this, if you understand, and you can go through soil investigation. And there are so many other parameters for soil investigation. I have file, I'll discuss it before also, I'll share it later on. Now it's very long file and I don't want to interfere in this statement of quality. That's, I would discuss with you. Soil investigation, you can say, a soul of your soil, if it's correctly done, it tells you what it is, how it works, where it works, what's important, what's not important. That's a very important factor in this. So, soil investigation, just I'll be back in 5 minutes. Hold on. soil investigation is talking about. Soil investigation is very important here. Soil investigation I was talking about, which you must understand and you must read. Don't take it that it's not your job. It's very much job of engineer, particularly civil engineer, because the basics of civil engineering, maybe you missed that one. Maybe you did not take much interest in your education time when you did degree, and maybe you don't like it because it's not concrete, it's not calculation much fun. Yes, there are calculations in that, but not to that level or so minute calculations. But remember, soil is base of building, base of base, you can say, foundation of foundation. It's so important. If soil does not work, your whole structure goes into waste. Therefore, soil is of highest importance, and its report, investigation report, which takes much time, much input, depending on types of layers, courses, to what depth we investigate, 10 meters, 20 meters, 30 meters, and of what depth layers change, maybe 1 meter, 2 meter. Somewhere you find soil, sandy, somewhere you find soft soil, somewhere you find clay, silt mix, limestone. It depends. If you refer to bore log report, you will get that. Every bore log is very important to understand what it says. Plate load bearings are not that many, few only, but bore logs you have to understand. You have to understand different layers also, and not only that, up to which you have to site your building, because below layers, underneath layers of your foundation do matter, because these respond in future. This can contribute to settlement of building or settlement of soil foundation level, or even cause uplift due to presence of water, and to what degree of presence water is. It's very important. Do not undervalue your soil report. Invest some time in that. Try to understand factors, parameters like value of n, like RQB, how it works, what it says. Of course, there are certain relations. What your thermal resistivity says, what your electric resistivity says, and what many tests conducted they say. Once you go through that, you shall realize something. That's what I say. Soil investigation report available. You study it before doing something, so that you have basic knowledge about what you are going to do. And margin for working areas to be established. Whenever you work, wherever you work, you must have some working area. Working area outside you're working, if there is no diaphragm wall. And if there is diaphragm wall, then it's different one. So margin must be allowed for working areas, which is very ordinary engineering. Means you must have certain working area around. Then value, as I explained earlier, this is statutory requirement, regulatory requirement. There are certain instructions, mandatory instructions, which you have to cope with. And I had given an example of electric pylon that I met on a site, and there was a requirement of 50 meters minimum distance from corner of building to that pylon, which we did not know at that time, and we had to shift that excavated building We have to fill back that excavation and do again another excavation after long gap of dispute. So follow up that means don't just move away. I'm a technical man, I'm an engineer, I have nothing to do with that. I have just to excavate and make building. Yes, you have to excavate and make building, but according to compliance of laws, according to meeting statutory requirements or regulatory requirements. That is where law involves in. Don't be a blank engineer. Be a comprehensive engineer. Be a commanding engineer. That's very important. If you are only a structural engineer or only a civil engineer, then you are not complete. You have to understand various extraordinary factors. Otherwise, without encroachment, you cannot move. So that's what I said about value. Then you have to know if there is some geographical report available. Means maybe sometimes geographical report or geotechnical report includes some indication about services existence, but if it's not given, no problem. You know which land it is, which plot it is, and which statutory authority in that nation is applicable onto that. And if you want to make sure whether or not live services are working in that area underneath that plot, you have to contact those departments, bodies, authorities for electrical live line, for water live line, for sewers live line, for many other live lines, live services. And also suppose your sites located in certain operating area, certain plant area, then this is more powerful. Your obstruction is more able. You have to contact those departments and authorities to find what are facts. Otherwise, this could cause big issue in future. If you damage that line, service line, and that line may coming to you or through your plot from different areas where some plant work is ongoing, facility work is ongoing, and if you crush that pipeline or electrical line, it's a big problem. You have to face, in certain cases, even imprisonment, as well as to pay heavy penalties. So this is very serious matter. Means that's what I say. Don't be civil engineer alone, or don't be structural engineer alone. Be a compact, comprehensive engineer, coordinating engineer, lead engineer. So this is running line services on, and once you discover, once you know that these are lines, these are available according to their drawings, which we call record drawings or as-built drawings, which you get from them, after moving real situation of site and everything, that what to do with that service. You have to contact that department, that section, that body or authority, and they will tell you what you have to do, or they will take care themselves. It's up to them. This question of contract, if you are paid in contract for existing services taking care of diversionary sector, then those departments will instruct you what to do, or else they will take care of themselves. That's a different matter. But remember, do not break these lines, particularly when you are in other than India, Bharat. Big issues are there, big laws are there. In your country, you can do whatever you want. I don't know, but if you work in Gulf countries, you work in Middle East, if you work in overseas, West or other countries, maybe you find very, very big issues, big consequences of that. If something happens, maybe you are in jail. Could be. So program for diversion, if required, to be decided with honor by authority, directly with honor, or through contractor. Sometimes I miss some spellings, don't take that way. For example, here it is item of serial number 14 is to contractor. Actually, this is through contractor, CHROUS. Sometimes it happens. I can't help it while working on words. I can't see something missing. Coordination with statutory bodies for all such services by contractor for honor. This is process, means you can do on behalf of honor if contract is as such, because you are paid for that in your lump sum price. Or if honor says no, he will help you, honor can do that. I don't mind that. Now, whether or not NOC required, you have to make sure. In some cases, NOC is required that the site is clear, will continue. If that is condition, then you can request for NOC from that relevant body. Safety mandatory measures to be adopted during excavations. I have already shown you some sketches, but if it's operating area, some other area where a specific requirement is to go to them and seek permission, that permission can be obtained in terms of you can say permit to work, PTW. Hot work or cold work permit to work you can obtain from there, and you must have some approval, some person approved from them, and then you have to make method statements, draw method statements, and for every work permit you require method statements, and that method statement is included with your application, and then they scrutinize that, authority people scrutinize that, and they issue you permit, limited duration permit. It may be hot work or it may be cold work. I think sometimes it is for 3 days, sometimes for 1 week, and there's a duration within which you can do that, but they should know what you are doing. This involves all safety measures, which are very strict safety measures in those areas, very, very strict safety measures. And quality, you should worry about yourself when you are in charge. As far as safety is concerned, traffic diversion is concerned, road crossings, diversion, or whatever else is concerned, it just happens. It happens. Now, what equipment to be used? You have to check your method statement. That's very important part. And also, are workers fully informed of site safety? That's also a very big point, because you are working in control area or otherwise. Your worker, you are duty bound for that, should know completely, fully and comprehensively about safety measures they have to use. All workers fully informed. You have to make sure, and addition to that, you must conduct toolbox talks directly to these workers or through your safety engineer or safety officer or supervisor. Toolbox talks is not a joke. Toolbox talks reminds every worker precautionary measures that worker has to adopt. This is not writing, this is explanation and getting answer from those people what is asked for. This is very important. Toolbox talks. Toolbox means how you are having tools for one activity or 2 activity or 3 activity at a time you are going to do. How shall you use those tools rightly so that you don't get injured by those tools. Injury can be on anybody's part, so you have to keep yourself safe. Otherwise, you too, where you may be little above the floor, or you are just waiting for something, you have got carelessness, lethargic, that vehicle comes and hits you, This is a very important point here. Now, I can say, also said that, so workers are fully informed, as I said, they should be, and they are. Now, go to another point. I just toolbox talks means I just try to add to this means I have one chapter toolbox talks that is somewhere else in this safety. I think I should show you that if possible. Let me see if I can show you that one. Something sometimes very important, sometimes not, but if it's better we try to show when issues come. Safety HSE procedures, safety policy. I have some tool stocks here. Oh, this is the one I want to see. What's that book? HSE book, HSE. Safety sketches, safety policy. This permit to work, and there is inspection and audits. Safe practices, what is that? I'm not finding it. Sometimes it happens with me. I feel upset with that. The sketches, nothing in the sketches, Safety policy, management system, site security, hand tools. Let us say hand tools, or it says hand tools. Just giving a brief about some here. Just I'm not that far not to find, but I'll give hand tools. Just a minute, please. Hand tools. It's fire. Trying to show you just the treatment of that. I'll show you that one just for showing. It's that. This is a file which is just giving you scope is that applicable to all project construction sites ongoing as well as okay fine. So the purpose of this is the definition regarding certain terms. Or safety means company, all that, leave it behind them. Responsibilities are there. Power operated hand tools, for example, it is general electric power. Operated tools, extension cords, use electric cords, pneumatic power tools. Then you can say, and we do the difference all hoses and fluid use, employees, manufacturers, systems, different others. Abrasive wheels and tools, woodworking tools, then jacks, lever and latchet, and compressed air tools. Then it is, hammers, wrenches, chisels, punches, screwdrivers, hand saws, hacksaw, pliers, picks and mattocks, shovels and spades. Like that means I'll take up later on to you as what is just I'm showing to you that this is possible that just trying to show you, but we're going to save some time. We'll discuss this. Safety related sketches. And tools. Then I have to take this to. Just let me save it, please. Just a minute, okay. So I can just save it. I'll put this file off now. Okay, I just try to show you outside and show you facial. What's the name? So I put this off now. Okay, so this is just a file I showed to you about tools for stocks. So you have to explain to them. I have to explain. Once I actually called my all staff in one project, all foremen, many, about more than 25 foremen there, and it was a business hospital project. Call them. Also call all engineers. I then, in conference hall, started talking with them, but they were surprised why I called them. All staff, site staff, not office staff. They work miscellaneous and nationalities, means different languages, but because they have some accident on site, I wanted to make sure how much they knew about tools arrangement, tools organization. All tools, grinder, hammer, small hammer, how to nail in, how to use your generator, small generator, drill, hacksaw, saw. Means small tool or big tool, power operated tool or non-power operated tool, whatever we do, there is a way to work on that tool with safety. My work is not for harming someone, not anyone. I have no right that my workers should be wounded, my staff should be wounded. I have no right. No such right I enjoy because I am in charge. Rather, reverse is true, that I have to keep them safe in each use. How that tool should be used, that person who operates it should know it. And maybe because that person forgets it, he knows it but forgets it. It's our duty to remind that person, to refresh that person what's best use of this. There are many tools, not one tool. Some are very dangerous, some are not. Some are power operated, some are not. But every work is important. Best use of that, considering ergonomics into our consideration, that talk should be given by some qualified safety engineer or officer who can train our foremen. If safety officer cannot do every day, then he must give talk to people, workers, as well as to supervising staff. It takes just, I don't think, more than 5 minutes every day. They can go to their locations also and explain. They are not necessary that everybody should come to safety person office. Not necessary. You have to tell them what's the best way of use and how you should use. You have to stand in position or you sit in position, or you have to avoid inclined position, and what is best way, whether you should use safety glasses or you should helmet or you should wear something else. And all this is very important point. This was toolbox talks, we call it. This is just indicative guidance I have given when we talk about toolbox talks, long chapter. So our workers, the question is, we have to ask question also, are workers fully informed of site safety, for which toolbox talk conduct is very important. Are shoring materials available on site? Check materials with shoring drawings. Shoring drawings. You must have certain drawings, and if you have to support them on site, support your earthwork or something else for excavation purpose, you must use those shoring material to resist falling of those excavated sites. Then question is, you have to enter into your trench, big one or small one, mass excavated one or otherwise isolated one. You have to go in and come out. We call it ingress and egress. Are ingress and egress to and from trench well planned? Well planned. You may ask, what is planning here? Yes, there is planning here. To go into something, some area, and coming out safe is well planned. If you come out safe and go safe. But if you meet some danger, if you meet some hazard, this is not well planned. So we have to check that provision. How we have to go in and come out, and what is circulation of workers there to move in out, and what is circulation of machines or equipment there to move in or out. Whether that equipment has to go in or just work from outside location, and whether we workers use ladders only all time, or we use ladders only in emergent time when there is some vehicle working or passing or some equipment working. That we have to keep in mind. So I have to check ingress and egress, because without ingress and egress successfully, you cannot work in that area. You have to come out and you have to go in all time, many times a day. So that's point here of egress, ingress. Are ingress and egress to and from trench well planned? Check provisions. Shall work be done? Shall work be done during night hours? That's another question. It is up to you, up to your project requirement, project demand, what it says. I have to understand this point, what project requires. It's not in my hand or your hand. If there is a need, you have to work at night, and when you have to work at night, you have to take permission, and when the permission is available, you have to take all actions required at night. That's a big question. Maybe you need police permission. Maybe you need something else. So shall work be done? Shall work be done during night hours? That question has to be answered. And for that you have to check regulations, rules, and whether that area is residential. If area is residential, generally permission is not granted. Because you can't sleep, you can't disturb people's sleep, you can't disturb their peace. And that's very small standard point we have to keep in mind. And whether police permission is required, that's to be obtained. And police won't give permission that easily. So is point of police permission, that is your paddock. Now stockpiles. Stockpiles areas. Stockpiles areas for excavated earth readily available. Stockpiles are stockpiles areas for excavated earth readily available. That is the point to be checked. What is a stockpile? Do you know that? Stockpiles of excavated earth. When you excavate for your foundations, you cannot keep that soil just there. And if it is just there, you keep temporarily. Immediately you have to shift that one, transport that one to other location. This is law of land. Maybe in industrial areas, industrial projects, or wherever there's space, there's no problem of space, or designated areas available, their stockpile has to be made. It may be your side part, an isolated part. Otherwise, you cannot keep site tidy, you cannot do controls on site after excavation is done and you keep soil there. That soil must be shifted, must be transported using your shovel and truck, and that truck takes this to designated area to drop or dump and come back to collect more. That is designated area where permission is available, and or if that is not public area, then it's your own area and your own soil, then on your soil is enough space you can keep there, keeping in view resortion to all environmental requirements, keep site hazard free, dust free, and also if you have a plan to mix that excavated soil with other imported good excavated earth, good material to mix up so that you can get coarse grading, you can get that materials combined grading to markable status. That can be done, and it can be screened out. Soil can be screened out. It can be mixed with dune sand. It can be mixed with some other graded soil, and it should be in such a way that it is purely cohesive material. Later on, graded material you get, adhesive material you get. So this is what I say stockpiles about. You can mix that. Sometimes you have to design your backfill material, which is not available in mass. Why we're talking of? Yes. Backfill material can also be designed, and it is designed as a procedure for that. So in that stockpile, an additional material can be added after screening. What percentage of material spent, that depends on your design. And you have to add there and then shift that material after adding to the laid below that foundation. That's a very important point. Now we have talked about this stockpile material. Necessary environment protection measures intact. That's all I say. I already said that. Regarding stockpile, you should keep in mind that it doesn't convert itself into dust storm and doesn't spoil site. It is well protected, and during screening it may cause problem, and during converting this stockpile and mixing it with other material, selected imported fill material, you have to mix it in some ratios that can also cause dust flow. So environmental protection laws, if applicable, then you have to dump this in whatever area is available. That's another point. And also rewatering arrangements. The watering arrangements you have to take care of. No, dewatering arrangement, whether or not required, that you have to decide. If it's required, we have to install that from very beginning itself before even starting your excavation. Dewatering arrangement by well point system, by other system, you have to do that. So dewatering arrangement, whether or not required, you have to check water table or sea report and decide which method to be used to be adopted, whether well point system or submersible pump in some system dewatering. Are oxygen cylinders available if so required in hot work areas or cold or confined areas, you may say confined areas? Are oxygen cylinders available if so required in confined areas? You have to make sure and take that from you. Are aluminum ladders according to requirement are available? Are aluminum ladders to requirement are available? That will make sure. Are aluminum ladders available, that is according to requirement? Or face masks available for all personnel is another question. Eyeglasses, safety glasses available or not? Toolbox document delivered or not? Emergency numbers are available there on site. Emergency communication system is available on site. And responsible persons, responsible personnel in so we have to keep all these points in mind: personal safety, work safety, group safety, toolbox stock, emergency requirement, responsible person to be dedicatedly present, site supervisor role, monitoring role. Then a water tanker availability. Is water tanker available for spreading water? Spreading water on ground to keep dust down? Or have neighbors located existing buildings in vicinity? You can say in vicinity the buildings, old buildings. Have you checked them, their foundations, or information you collected? Have neighbor located existing buildings been checked? Possible adversity, subsidence in case of deep excavations. In case of deep excavations of the watering, check and ensure stability. What is stability? Again, I am telling you why I am talking of these points, very important from engineering point of view. Vicinity buildings, and you are going to deep in-depth excavation. First of all, maybe those buildings are above foundation above your level. Means neighbor buildings are situated there in clay soil, example, even sand soil of weak strength. So that point is of use of water table and water. Then you can say neighbor building or vicinity buildings are maybe big, have foundations, good foundations probably, but when you dewater, there is chances in clay soil. In clay soil, when you pump water, water may come from distance also, because water can come depending on nature of soil and connectivity of pores, to what extent permeability works there, and to what extent, Philistine works there. There's a question which subsistence can, when you pump water, you pull water from distances, also break soil particles in that, and not one soil particles, maybe millions of soil particles can pull from that, which can cause settlement of that foundation. You have to be very careful about that. There's less chances in sand, but in clay there's chances of water particles bringing with it, soil particles. So for excavations in certain areas, mechanical excavation cannot be applied without ensuring about live lines, ensure status. You can say in such areas where there is no water yet, Aram, it's okay. We'll take care of this later on, right? Okay, fine. Okay. That's fine. So let's go to now. Time to close this. Time to close. I'm going down now.